When the temperature of the refrigerant flowing to the compressor drops, a temperature sensor sends a signal to a controller, which in turn sends a signal to the bypass line control valve, causing it to open slightly. This allows some of the refrigerant from the discharge of the compressor to be routed to the evaporator. This warmer refrigerant mixes with the refrigerant leaving the expansion valve and increases its temperature. As a result, less heat is removed from the substance being cooled, and its temperature increases back to the desired value. Another way that refrigerant flow can be controlled in refrigeration systems that have centrifugal compressors is by using dampers or vanes. These devices are often located in the compressor suction line. When the temperature of the substance being cooled is too low, the temperature of the refrigerant flowing to the compressor drops. The dropping temperature is sensed by a temperature sensor, which sends a signal to close the vanes slightly. This reduces the amount of refrigerant that enters the compressor, so the flow of refrigerant decreases. The reduction in flow will cause the refrigerant in the evaporator to be warmer. This causes the temperature of the substance around the evaporator to increase back to its desired value. Now, these controls are not the only ones you may find on a refrigeration system. For example, in some systems, a temperature instrument measures the temperature of the refrigerant and sends a signal to control the flow of water or air through the condenser. This, in turn, controls the amount of heat rejected from the system. This is another type of control system found on refrigeration systems with centrifugal compressors. This system measures refrigerant temperature and sends a signal to the controls of the compressor. This signal, in turn, controls the compressor's speed to maintain the desired amount of cooling. A vapor compression refrigeration system may have many indicators to help operators monitor and control the system. These indicators are often located on a panel so that operators can check the operation of the system from a single location. Operators routinely check the temperature indicators associated with a refrigeration system. In most cases, there are temperature indicators for the substance being cooled and for the discharge of the compressor. The condenser and the evaporator may also have temperature indicators located on their inlets and outlets. These indicators can be checked to see if heat transfer is taking place properly. Besides temperature indicators, there are also pressure indicators that should be checked. Two common locations for pressure indicators are the suction and the discharge of the compressor. Operators can use these indicators to monitor compressor operation. Some compressors have a lubrication system that uses an oil pump. The discharge pressure of the oil pump should also be checked. The correct discharge pressure indicates that the compressor's bearings are properly lubricated with oil. There are also level indicators that should be checked. Two common locations for level indicators are on the receiver and on the oil reservoir for the compressor's lubrication system. The level indicator on the receiver monitors the amount of refrigerant in the system. The proper level of refrigerant must be maintained in the receiver to ensure that an adequate supply is available. The level indicator on the compressor's oil reservoir is checked to see if the compressor has enough oil for proper lubrication. If the oil level drops too low, bearings and other moving parts may be damaged. Now, there may be other indicators you should check to ensure that a system is operating properly. For example, sight glasses on the receiver outlet can be used to check the flow of refrigerant. Ideally, a vapor compression refrigeration system will run efficiently and practically by itself. Sometimes, however, problems may occur. One of the more common problems that can affect a refrigeration system is an improper amount of refrigerant. The amount of refrigerant can be determined by checking a level indicator on the receiver or by checking a sight glass on the receiver outlet. When the amount of refrigerant in the system is correct, the refrigerant seen in the sight glass should be clear. If there's not enough refrigerant, the refrigerant may appear cloudy and it may contain bubbles. Another indication of too little refrigerant may be a continuously operating compressor. Some types of refrigeration systems cycle the compressor on and off to maintain the proper cooling. If this type of system has too little refrigerant, the compressor may run continuously, trying to maintain the desired amount of cooling. A similar problem is low refrigerant flow. One place where this is a problem is in the evaporator. When refrigerant flow through the evaporator is too low, less heat will be removed from the substance being cooled. This will cause the temperature of the substance being cooled to increase. The compressor may also provide an indication of a low flow problem. In a system with a reciprocating compressor, reduced refrigerant flow causes the pressure in the evaporator to decrease. and the control system may shut down the compressor. When the compressor stops, the refrigerant begins to warm up and the pressure starts to rise, so the compressor quickly restarts. Then the pressure is reduced again and the compressor again shuts off. This on and off cycling or short cycling will continue as long as there is a low flow condition. One possible cause of reduced flow through the evaporator is a stuck expansion valve. Dirt or scale can obstruct the valve and prevent it from opening properly. The same result can occur if there is a blockage between the receiver and the expansion valve. The blockage acts like another expansion valve, so the refrigerant will be cooler downstream from the blockage. One way to check for a blockage is to feel the line for cold spots. Now, a refrigerant flow rate that is too high can also occur. If the expansion valve sticks too far open, there may be too much refrigerant in the evaporator. This could cause the evaporator pressure to increase. In systems that cycle the compressor on and off, the compressor could operate continuously. This is because pressure in the evaporator is higher than the set point for shutting off the compressor. Another problem that can occur is a reduced condensing rate in the condenser. This can increase the pressure on the discharge of the compressor. What do you think happens if the pressure gets too high? In many systems, when the compressor discharge pressure builds up, the high pressure switch will shut off the compressor. There are a number of reasons why discharge pressure can build up from a reduction in the condensing rate. For example, a blockage between the condenser and the receiver will back up the refrigerant. This reduces the amount of condensing that occurs and increases pressure. Another cause of a reduced condensing rate is a decrease in the flow of cooling water. For instance, a blockage in the cooling water system could reduce the flow of water through the condenser and reduce the amount of refrigerant that can be condensed. Other possible causes of cooling water flow problems include cooling water valves being out of position and cooling water pumps not operating properly. Air binding in the water side of the condenser or in the cooling water system could also reduce the condensing rate. Compressor malfunctions can cause problems in a refrigeration system. Typical causes of compressor problems include loose or broken parts, worn bearings, and inadequate lubrication. Overloading is another refrigeration system problem. Overloading occurs when the area or substance that's being cooled contains more heat than the refrigeration system can remove. In this situation, the compressor may operate continuously, but the desired temperature will not be reached. Another problem that you might encounter is icing on the evaporator. This can occur if the system cools a space to below 32 degrees Fahrenheit and the space contains moisture. Under these conditions, ice forms on the evaporator and acts as an insulator, reducing the efficiency of the system. In this topic, we looked at some of the basic controls and indicators that are found on many refrigeration systems. We examined some of the operating checks that should be made on a typical refrigeration system. And we looked at some problems that can occur in refrigeration systems. Now try some practice questions on refrigeration system operation. To operate properly, a refrigeration system must control refrigerant pressure and flow. In a system that has a reciprocating compressor, the flow of refrigerant is produced by the pressure exerted on the refrigerant in the compressor. Some types of refrigeration systems maintain the desired amount of cooling by cycling the compressor on and off. This controls the amount of refrigerant that flows to the evaporator. In many systems, refrigerant flow, and therefore the amount of cooling, is controlled by an expansion valve. The position of the expansion valve is controlled by the temperature of the substance being cooled. Some control systems use a thermostat located in the area being cooled to position the expansion valve. Other systems may use a thermal bulb or a thermocouple.
In this example, the operator notices a trend developing on the moving X-bar chart. The plotted values are moving toward the lower control limit. The moving R chart appears normal. Even though the moving R chart appears normal, the pattern on the moving X-bar chart indicates that the process is unstable.
Reactions that produce heat after they're started are called exothermic reactions, while reactions that require heat to keep them going are called endothermic reactions. Equilibrium reactions are both exothermic and endothermic. If an equilibrium reaction requires heat to keep forming products, it will produce heat as the products revert back into reactants. Operators routinely check the temperature indicators associated with a refrigeration system. In most cases, there are temperature indicators for the substance being cooled and for the discharge of the compressor. The condenser in the evaporator may also have temperature indicators located on their inlets and outlets. These indicators can be checked to see if heat transfer is taking place properly. When refrigerant flow through the evaporator is too low, less heat will be removed from the substance being cooled. This will cause the temperature of the substance being cooled to increase.